Okay, let's continue with lesson 4-1, example 3, add rational expressions with unlike denominators. What is the sum of x plus 3 over x squared minus 1 and 2 over x squared minus 3x plus 2? So now we have learned how to find the LCM polynomials. We're going to use that to add rational expressions. So here we have polynomial denominators that are not alike. So we're going to factor them out first and see what the LCM is. So factor out x squared minus 1, we have x plus 1 and x minus 1. And then factor out x squared minus 3x plus 2, we have x minus 1, x minus 2. And so your LCM is going to be the factors of each kind, different factors with the highest degree of power. So here you have x minus 1 and x minus 1 repeated. So we're just going to multiply x minus 1 once though, because the highest power would be just 1. So x plus 1 times x minus 1 times x minus 2 would be the LCM. And whatever the factors we don't have for the denominator, we're going to multiply that by the numerator, because in order to make the same denominator and match our denominators, we have to multiply by that factor, with 1, right? So that we don't change the fraction. So multiply x minus 2 over x minus 2 on the first fraction, and multiply x plus 1 and x plus 1 in the second fraction. And then you're going to have a bunch of factors in the denominator, but do not multiply the denominators out yet, because we might be able to cancel out later. So on top, in the numerator section, we're going to multiply them out first and then combine and simplify. So distribute, and then simplify like terms with the like terms and see if you can factor them out. Yes, you can. You have x plus 4 and x minus 1, and it just happens that you can cancel this factor out, right? X minus 1 and x minus 1. So then whatever you have left would be x plus 4 over x plus 1 times x minus 2. And we know that the domain cannot be 1 or negative 1 or 2, looking at our original problems, our original rational functions. So you can simplify and then state the domain. That is your final answer. Let's look at number 3a. Try number 3a and b. See if you can solve this by yourself. Pause the video and come back when you're ready for answers. Okay, are you ready? Are you ready to check the answers? Let's look at 3a. So we have x squared minus 4. That could be factored out to x plus 2 and x minus 2, right? And then x squared minus 5 plus 6. So you would automatically think, oh, I can do negative 6 plus 1 just by looking at negative 5, but it has to be plus 6, not negative 6. So you have to think about other factors like 3 and 2. And in order to have a positive 6 of a sum and then negative 5, positive 6 as a product and negative 5 as a sum, your only combination that works is negative 3 and negative 2. So looking at our factors of the denominator, our LCM, we have a repeating factor. Our LCM would just be x plus 2 times x minus 2 times x minus 3. But obviously we have x minus 2 as a common factor, so you don't have to multiply that out. You just have to multiply whatever factor you don't have. So the LCM is going to be x plus 2, x minus 2 times x minus 3. And then for the first fraction, you're multiplying x minus 3 over x minus 3, right? So you're multiplying x plus 6 times x minus 3. And then the second one, the second term, you're going to multiply x plus 2, right? So 2 times x plus 2. And then you multiply them out in the denominator. So this is going to be, use the FOIL method. And then you have x squared plus 3x minus 18 plus 2x plus 4 distributive property. And then this one becomes, if you add the like terms, you have x squared plus 5x minus 14. So here you can factor out this polynomial and have x plus 7 times x minus 2. So in the numerator, you have x plus 7 times x minus 2 all over x plus 2 times x minus 2 times x minus 3. And so you can cancel this factor out, and you can't do anything else. So your final answer would just be x plus 7 over x plus 2 times x minus 3. And let's practice stating the domain as well for all values of x except your initial denominator that are zeros. So except -2, -3, and +2. Okay, so that would be our final answer for part A. Let's look at part B. You do the same thing. You have, you're going to factor this out because this one is non-factorable. So factor this out, you have 3x plus 4, and usually this is a hint, right? That's a factor. Then you have 2x because you have a leading coefficient of 6 minus 1. And then you see that the LCM is your denominator in the second term. So you don't have to multiply anything to the second term. You just multiply 2x minus 1 in your first numerator. So you have 2x times 2x minus 1 plus 4x squared minus 11x minus 12 all over your LCM. 3x plus 4 times 2x minus 1. So your 0 would be x will not equal to -4 over 3 and 1 over 2, right? Those are your domain. And then you're going to multiply them out. You have 4x squared minus 2x minus 4x squared minus 11x minus 12 all over the same factor, 3x plus 4, 2x minus 1. And then you add the like terms. You have 8x squared minus 13x minus 12 all over 3x plus 4 times 2x minus 1. And the polynomial in the numerator, you can't really factor that out, so you can just stop there. And then for all x except -4 over 3 and 1 over 2. Okay, so those are the answers for 3A and B. Answers, if you got it right. If you did, great job. Let's move on to example 4. Subtract rational expressions. What is the difference between x plus 1 over x squared minus 8x minus 16 and x plus 1 over x squared plus 6x plus 8? So here now we're going to subtract polynomials instead, right? But it's the same thing. You just have to make sure that you distribute the negative out in your second term when you do that. So find the LCM after you factor them out, then multiply them out, but make sure that your second term here, they're all subtracted. Okay, so you distribute that out and it's all subtracted. So that means you need to multiply the negatives out if you want to make all of them addition. And then you simplify and see if you can cancel out anything. You can't, so you're just going to write the final answer as it is for all x except for -4, -2, and 8 from your first denominators. Okay, let's look at try number 4 and simplify A and B. Simplify as much as you can. Pause the video, see if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? Let's look at 4a. Your denominators are 3x, 6x, and minus x squared, right? You have 3x, and then 3 times 2 times x, and then you have x times x. So the LCM is going to be 6x squared, right? So you're going to match everything, multiply the first numerator by 2 because you don't have 2x. By 2x, right? And so you have 2x, and then multiply this by x, plus x, multiply this by 6, so negative 6. And then you have 6x squared for the denominator, and simplify 2x plus x is just 3x minus 6, and then you can factor 3x minus 6 out. And then you can simplify this. So your final answer is x minus 2 over 2x squared for all x except 0. Okay, good. What about part B, 4b? So this one, if you factor the first denominator out, you have x minus 5 and x plus 5. So the LCM would be just x squared minus 25, right? So your first fraction, you don't have to multiply anything, but the second term you have to multiply by x minus 5 because you don't have that factor. So 3x minus 5 minus 2 times x minus 5, and don't forget your second term is subtracted. And then all over x minus 5 times x plus 5. And so you can simplify 3x minus 5 minus 2x minus 10 all over the same factors. And you have 3x minus 5 minus 2x plus 10. And then you simplify, you're going to have x plus 5 all over x minus 5 and x plus 5. And then now you can cancel this out, and you just have 1 over x minus 5 for all x except positive and negative 5. This is your final answer. Check your final answers, see if you got it right. If you did, good job. We'll continue with example 5 and 6 in the next video.